Well, here's a problem where we're looking for a time for how long it's going to take a sample to decompose to 12.5% of its original value. So we're looking for N2O5 decomposing to NO2 and O2. We're given a rate constant of 1.7 times 10 to the minus 3 inverse seconds. We've got a couple of different ways that we can work this problem. The first way that we'll do it is, since we're given a K, we can calculate a half-life, and we've got this 12.5% here, which tells us something about how many half-lives it's been through. It tells us that we've gone through 3 half-lives exactly to get to 12.5%. So we'll just kind of do it that way first, and then I'll show you a little bit different way that we could use for any percent. The first method we're going to use, we can only use because we are on an exact number of half-lives here. So for this first way, first thing we need to do is to calculate our half-life time. So we know that T1/2 is equal to natural log of 2 over K. So that's equal to natural log of 2 over 1.70 times 10 to the minus 3 inverse seconds. And when I calculate that out for a value, I get a half-life time of 407.7 seconds. Now, for determining how many half-lives we're going to go through, we know that we start at 100% of our material. After one half-life, we're going to be at 50%. After another half-life, we'll be at 25%. And then after a next half-life, we'll be at 12.5%. And so we see that it takes 3 half-lives to get to 12.5%. And so the amount of time it's going to take to do that is going to be 3 times 407.7 seconds, and that becomes equal to 1223.2 seconds. Okay, so that was the first way to do it. And again, you can only use that method if you are going to be in an exact number of half-lives, which 12.5% just happens to be. Let's look at a second way of doing this one. And so in the second method, we're going to use this equation here. We're going to say that the natural log of concentration of A at time t over concentration of A at time 0 is equal to negative kt. It's a little t for time. And so here we're not told what my original concentration of A is. We're not told what our concentration of A is at some time t. But what we are told is that we are at 12.5% of its original value, and that tells me that this fraction right here is equal to 0.125, which is the decimal version of 12.5%. And so we can now set up this equation like this. So we're going to have natural log of 0.125 is equal to negative k, which is 1.70, times 10 to the minus 3 inverse seconds, times my time, which I don't know. But I can solve for that time, and when I do that, I get a t value that's equal to 1223.2 seconds, just like we did before.